Good morning, everyone. Today I'm going to share with you all some results from a study we are conducting here at the Wiregrass Research Station in Headland, Alabama. We established a trial in a cotton and peanut rotation down here where we evaluated 8 different cover crop treatments, including a winter fallow control, as well as monocultures of rye, crimson clover, and daikon radish, as well as any combination of those 3 cover crops. This is the 3rd year of this study, and in the first year and in this most recent spring of 2020, we saw no differences in cover crop biomass between the 7 cover crop containing treatments. However, in the spring of 2019, we did observe several differences in cover crop biomass, some of which are reflected here. Here we show the biomass for the rye clover mixture about a month before we terminated our cover crops, as well as the rye monoculture taken at the same time. We can see that the rye monoculture at the time of termination developed about 3,400 pounds per acre of cover crop biomass, while the rye clover mixture had significantly more biomass at 8,300 pounds per acre. However, we can see in this picture of the mixture as well as the monoculture that the rye stand was a little bit sparse. However, in the few weeks before we terminated the cover crop, the crimson clover really flourished and helped to fill in some of the gaps left by the rye, which is one of the benefits of establishing a cover crop mixture. When one of your crops is not doing so well given the conditions when they were growing, another crop can fill in those gaps and perform quite well. However, because of that, cover crop biomass can be quite variable from year to year. And so we also evaluated in this study cover crop decomposition over time. We divided up biomass for 5 of our different cover crop treatments into decomposition bags, such as these, and we sampled those cover crops again at 2 weeks, 6 weeks, 14 weeks, and 26 weeks after cover crop termination. We might need to splice it here.
There's no good way to do this.
Yeah, it is awkward.
Should I start over with a decomposition with this?
Yeah, just do it that way,
I was
just
kind
in
of doing
case.
it in the middle of your,
All right.
sorry.
All right. I'm going to start talking about the soil health first and just say there are no differences. Is that good?
Well, since you're already talking about the biomass, I would just do that and then move into the soil health. And,
Okay.
yeah.
So in this study, we evaluated cover crop decomposition over time. We divided our cover crop biomass for 5 selected treatments into bags such as these, which we then proceeded to sample 2 weeks, 6 weeks, 14 weeks, and 26 weeks after cover crop termination. And the decomposition over time is reflected here based on the cover crop biomass that we sampled in the spring of 2019, which was also planted in the fall of 2018. We can see here that the rye clover biomass was really quite high compared to the other cover crop treatments shown. However, we also see quite a steep decrease in cover crop biomass after 2 weeks, with only about 2/3 of the initial biomass remaining. Meanwhile, the rye clover radish biomass just below it kept about 3/4 or to 80% of the initial biomass at the same point 2 weeks after sampling. And by the time we reach the 14-week point and especially the 26-week point, the remaining biomass gets closer and closer. And by the time we are 6 months into the peanut growing season, the remaining biomass is virtually the same. If we look down below at the clover and rye monocultures, we do see that the clover monoculture actually had higher initial biomass than the rye monoculture. But we do again see that there is a steep decrease in cover crop biomass after 2 weeks, with the crimson clover monoculture having just above 50% of its initial biomass remaining after 2 weeks, while the rye monoculture kept about 85% of its initial biomass at the same point.
Carbon and nitrogen ratio.
And these differences in cover crop biomass of cover crop decomposition are due to the dramatic differences in cover crop carbon to nitrogen ratio that we see between the rye and crimson clover crops. with the rye, with cereal rye having a much higher carbon to nitrogen ratio than crimson clover. Because of that, it will remain on the soil surface for longer throughout the growing season, which means that a heavy rye cover crop will remain on your soil and provide some benefits, including soil moisture retention and potential weed suppression throughout the growing season to a greater extent than your crimson clover, assuming that they start at the same biomass level. And so for these two, for this trial, we also evaluated, we can splice this.
Okay, yeah, we'll stop, pause.
That's a little more
They start talking about jellies.
Nah, all right. Okay.
Yeah, cotton was first, so.
All right. So as I mentioned before, this trial was established in a cotton and peanut rotation. However, in 2018, when we had cotton growing as our cash crop here at the Wiregrass Research Station, we lost our yield due to Hurricane Michael. However, this same trial was conducted at the E.B. Smith Research Center in Shorter, Alabama, and those are pretty similar environments, so for the purposes of this video, we are showing that yield data. We can see here that the rye and rye clover radish treatments did have significantly higher cotton lint yield than our winter fallow and clover radish treatments, with the rye clover mixture performing quite well in terms of lint yield as well. In 2000, with a difference of about 400 pounds of lint per acre difference between the rye and rye clover radish treatments compared to winter fallow. If we look over here at the 2019 peanut yield that we had here at the Wiregrass Station, we see quite different trends. However, they are not quite, they're about what we would expect. We can see that the winter fallow and daikon radish treatments did have higher peanut yield than all of the crimson clover containing treatments, with a difference of at least 1,000 pounds per acre of peanut yield for each of the clover treatments compared to the winter fallow control. This is likely due to an increase in disease pressure caused by a legume rotation, which is generally not recommended for peanut producers here in Alabama.